This video will specifically focus on how to solve stoichiometry problems when I'm given a number in gram and asked to solve for how many grams of something else are created. It doesn't matter if I'm given an amount of reactant or product. It doesn't matter if I'm asked about an amount of reactant or product. No matter what, each time you're going to calculate these the same way. So step one is always to write down the given number. And in this case, there's one number given to you, which is 35.3 grams of copper 1 sulfate. As I've said before, the nice thing about stoichiometry problems is when I'm giving you the words and you're panicked because you don't know what the substance is, you are given the equation, and all you need to do is look up at the equation and identify which one is copper sulfate because I've given you the recipe. So the compound that I have 35.3 grams of is copper sulfate. The question is then asking me to solve for how many grams of aluminum can I react with it. So aluminum is this part of the equation. So you're literally matching up exactly what the things are. Now every time you're going to be multiplying by a conversion factor of some kind that allows you to convert from the dimension you're in into a new dimension. And to make it easier if you want, you can put this over 1. So far we've seen every time that whatever label and substance are here, those are what end up coming down to the bottom of our conversion factor. Okay. So step one of a gram to gram problem is to go from gram to mole. Because in stoichiometry, if I'm not in mole, I want to go to mole. Now, when I see gram per mole like that, that is what's called molar mass. Okay? And for molar mass, when I'm going to mole, I'll be going to mole of the same substance that I was in for gram. When it comes to setting up these numbers then, how many moles I have for copper sulfate per how many grams of copper sulfate, that's what the molar mass is. So you'd go to the periodic table and you would add up all of the numbers for the copper twice and the sulfur once and the oxygen 4 times. And I did give you that number right here, so you don't have to do it yourself. So the relationship between gram and mole for copper sulfate is that a mole of copper sulfate, if I have 6.02 times 10 to the 23rd of copper sulfate, that will mass out to be 223.148 of that substance. Now I'm not done with the problem because I haven't gotten to aluminum and I'm not even in grams anymore. So by setting the problem up like this, the grams cancel, as do the copper sulfate, but I did move in to moles of copper sulfate. So I'm going to multiply by a second conversion factor to continue to get my labels to change. As it works with conversion factors, whatever label is here or on top is now the label that I'm in, and that is the label that's going to come down. So never the number, just the label. What a lot of people tend to do wrong for stoichiometry are two things. They try to make the number before the label, and they try to make the top before the bottom. So when it comes to conversion factors, I would say always work bottom to top, and then also always work label, then number. Okay, because otherwise you just tend to make mistakes. Okay, so now that I'm in mole of copper sulfate, this is where I can go to moles of aluminum. So this is my mole ratio. This is what stoichiometry is by definition. So this is the key that unlocks the door that allows me to do stoichiometry. Okay. Now once I've set up the labels, now I can focus on, well, what is the relationship between these two things? And what the relationship is between aluminum, moles of aluminum and moles of copper sulfate are the coefficients. So for every 2 aluminums that I react, I need to also have 3 copper sulfates. That's their ratio. So for every 2 moles of aluminum, I'm going to need 3 moles of copper sulfate to make that work. Now the problem's almost done. I want to get to grams of aluminum. Now I'm in aluminum, so that's great, but I'm not in grams yet. So I'm going to do one more step. Again, now because of how it's set up, this is where I am because I was able to cancel out mole and copper sulfate. So now what I have is moles of aluminum, and from moles of aluminum, I can go to grams of aluminum by using the molar mass of aluminum. And the molar mass of aluminum is something you can find on the periodic table. Depending on the table you have, I got 26.982 grams per 1 mole. At this point, you can now stick this in your calculator. It'd be 35.3 divided by 223.148 times 2 divided by 3 times 26.982, and that would give you your answer for this problem. Now your calculator gives you 2.84554, and that'll be in grams of aluminum. But the last thing you need to do is round it to the number of sig figs based on what went in. So this has 3 sig figs, and that's what went in. So I have to round my final answer to just 3 sig figs, and that's what the final answer would be. It's an example of a gram to gram problem. In general, they will always follow the same procedure. I'll be given some amount of grams, so I'll need to convert that number of grams to moles, where for every 1 mole, it's however many grams I have from the molar mass on the periodic table. Then I'm able to convert from moles to moles of whatever I'm in to whatever I'm trying to solve for. Those numbers then, for that problem, those can always be found from the coefficients. So you need a balanced chemical reaction to do that step. The last step then, since you're trying to go to gram, will always be 1 mole on the bottom and some number of grams on top, found from the molar mass on the periodic table. And that will be for substance B, since that's the substance I'm in now. One thing to notice, and I often point this out, is if you cut your problem like this, everything going this way is substance A, or the substance you're starting in. I'm starting in A, I'm doing molar mass of A, and then the mole of A is on the bottom. At this point, I can change to B, and from there on out, everything is B. So the magic point where I can switch from A to B is the molar mass, and that is how it will work every time. So that's an example of a gram to gram problem for you.